So I'm Elizabeth Cooper. For those of you who haven't been here, I think everybody knows that now. And this is, as I said, the third of 6 scheduled talks this year. Next month is going to be Taylor Roberts, who comes from Group 14 out of Denver, and he's going to be talking about modeling for LEED v4. So if you're doing any LEED projects, then it should be a good talk to see how to approach that. So this year's our lab, more or less, it's always changing because of students. So we've got a new faculty member coming soon as well. And then I'm sure over the summer and into the fall, we'll have some new students. We get a lot of our funding through generous support from Idaho Power, including the BSUG series, as well as Foundational Services, which is our technical design assistance program. Many of you are familiar with that, so we don't need to spend too much time. Also available, one of the programs that we developed is our building metrics labeling. It's essentially a green lease sheet, so something to maybe make known to your clients. It gives an EUI, walkability score, some daylighting information. So online, easy tool. Our tool loan library, nearly 1,000 tools at this point. Everything from power to gas, gas and liquids, light, thermal imaging cameras, very popular one, that sort of thing. A free resource to all you guys. And then the Commercial and Industrial Energy Efficiency Program, always like to mention this. It's an Idaho Power program, offers incentives for advanced systems, energy efficiency systems, whether that's advanced lighting systems or advanced mechanical systems, and always something to check out if you're trying to pursue any energy efficiency goals. So assistance there through incentives. So, and today we have our homegrown speakers. Dylan Agnes received his master's in architecture from the University of Idaho year and a half ago, something like that, year and a half ago, and has been at the lab for 2.5 or 3 years, something like that. And lose track. And he has become really the go-to guy for us for lighting, both natural and electric lighting, and has become pretty proficient at the often complicated world of radiance, and he's going to talk about that today. And then the second speaker is Damon Woods, who is very, very close to getting his PhD in mechanical engineering. Is neck deep, eyeball deep in his dissertation right now. Will be defending next month. So he was kind enough to take a few moments out of his weeks. And so it's great because we get to see him because he's been hiding over in his office for a while. But he is going to talk to us more specifically about the energy modeling side of things. So 2 components that a lot of the engineers and architects are looking for, both daylighting that Dylan's going to talk about, and general energy, whole building energy modeling that Damon's going to talk about. Because again, they have a lot of material they want to cover, we'll send it over to them.
Okay. Riker, can you hear me okay? Okay. So today we're going to start off with pretty much what you guys usually work in, which is Revit, AutoCAD, Autodesk-based modeling products. So the 2 most often that we get are Revit and AutoCAD. But for energy modeling, we prefer 2D export. So we want your plans, sections, and elevations to make the model. We'll go into that later. For daylighting model, I generally prefer the 3D model, if possible, just because it cuts down on modeling hours and potential errors that could happen from me just making the model from scratch. That help us along the way for daylighting, daylight area drawn out or shown. Lighting types, side lighting is all the natural lighting coming just from the side windows, or that clear stories, or their skylights or solar tubes. Material schedule, as best as you can. We know projects, aren't always complete or, are constantly being defined or changed. So we would like to know, as much often as possible, give us an update of what materials are being used to construct the space and the building and wall types. Room schedule, that's for area, and just so we can separate the spaces out for code for running simulation. Lighting schedule, if you're doing photo control, daylight harvesting. Window schedule, window seal heights, fenestration area, that sort of thing. For energy modeling, it's a little more complicated. They want the zone. Damon would like your zone designations, window to wall construction properties, similar to me. Space type definitions, lighting, plug load, occupancy, infiltration estimates. Again, as soon as you get those or as often as you update them, just send them to us and we'll just update our model as we can. Your HVAC system type. It's okay if you don't have that right away. We'll just use ideal air loads, but the sooner you get that to us, the better. Equipment schedules and operation schemes. To export for 3D, you must be in the 3D view. But before we get to that, we're going to set up some of our parameters and options with the Options tab. And that's going to bring up this window. And the most important thing for exporting a 3D model in Revit is that you have this checked. These are, layers is probably the second most important. The other ones, not so much. They matter for 2D exporting. Is polymesh versus ACI solids. Revit's kind of tricky that it has two types of geometry, one for rendering on the computer and the actual geometry. It will export that what the object is made of. So a good example of that is a mesh you'll apply for a shading device that seems perforated, allows light through, but when you actually export it, it's actually a solid because it's a poly mesh that's been applied to it. And that's just for you to see the effect of it on your computer screen. So the difference is that you get about 6 separate objects versus 1 object. So that makes your model a lot bigger and it makes it a lot more complicated to work with. Tab would be the layers tab. That's just because of the way Revit classifies its families, wall types, and grouping. And then that also changes even more depending on the individual modeler. Export, this is what you're going to get. Okay. Yeah, how's that? Okay. So this is what you're going to get if you just leave the defaults. Very confusing. You have to kind of wade through it, and some things are separated out and that just make it way too complicated. Here's kind of a key for what those categories mean. The ones that are most important are probably the walls. Revit kind of only does 2 categories, a wall and interior wall, so you have to go in and separate those out. So here's an example of that being done. Just want to rename the layer type. I go ahead and do this for both if I'm using a model. The cut one is for 2D. The projection is for the 3D export. So you just want to, and you can change this as you see fit. And one of the good ways of testing this is just to make some changes, bring it into SketchUp, and see what categories pop up and what's being sorted into which groups and layers. So here's an example of what I do, how I break down the A wall and the I wall categories. I leave it as other wall just because of certain wall construction types where it's layered and you have like a CMU with a brick, and then you have the window fenestration area, and then you have the foundation wall of it. So some of those I like to leave separated just so I can go in and make sure there's no gaps or anything that's going to cause problems. The other most important thing is the visibility and graphics manager. So this option is second in command. So anything you make in here will override this, but you still need to set this up. So this is important for a 3D view. And basically what you need to do is go to the filters list. For us, this is our preferred method, and just uncheck everything except architecture. The rest of it I do not need, and Damon does not need either for the energy model. So also some examples, instead of hiding stuff, like you could have a couple random sorted doors together. Interior doors aren't necessary for energy model simulation or daylighting model, so I'll take liberty and just go ahead and remove some modeling geometry within the project. Be careful though, make sure you have a copy of the original file saved before you do anything, before you do any editing like that. So here's an overview of what I typically leave unchecked that I want exported. Generic models is on there because when you create a component or a family, a new family, or you're customizing a family, generally what I found is modelers will leave it on the generic one. So I'll export a model. If I have this unchecked, and all of a sudden I'm missing an entire window group, or I'm missing, you know, bay doors to an apparatus bay, just because it wasn't categorized properly. So that's just something to keep in mind, is to keep your families and your naming in order for Revit. So for 2D export, you're going to do the same thing with the layers. The only other important option for this would be the lines option. You want to make sure and color, depending on if you want to color code your layers, but make sure none of your lines are hidden and that they all have a readable line weight, so at least 1 or higher. Otherwise, SketchUp's not going to pick it up when you import it. So to import into SketchUp for 3D, you're going to go to File, Import, AutoCAD Files. You should know that you have to have a pro version of SketchUp to do this for any Autodesk product if you want to import it in. And the other caveat is it has to be 2010 or earlier. So for 3D export, you want to make sure you have this checked, merge coplanar faces. And you want to use default model units. SketchUp will take care of that just fine. So the reason why you want to have that checked is because this is what a wall will typically look like if you don't. So it has triangulated faces. So potentially with Radiance, you'll have trouble defining this geometry and light can pass through it. So if you have that option checked, it gets rid of that. And that just has to do with the way Revit builds its geometry. For 2D, you're going to do the same thing, except you're just going to leave everything unchecked and just have the model units. So that kind of takes care of the Autodesk and products and how you kind of get them into SketchUp. Mm-hmm. So Radiance, and basically why we use it. It was intended to aid lighting designers and architects by predicting light levels and scene comfort, basically glare probability, prior to the space's construction. Why it's so useful is that the simulation uses backwards ray tracing to compute radiance values. That helps cut down on simulation time compared to other engines that run, as well as just maintaining accuracy. The results can be analyzed, displayed, or manipulated within the package. So you basically convert it to other file formats that you need. So TIFF, HDR, so you can use it in Photoshop or Illustrator. And the software is open source. That's probably one of the worst things about Radiance, because it has a steep learning curve, has a non-existent user interface. We'll go over that later. And troubleshooting, in my opinion, is what prevents it from being a mainstream software program. So the reason why we like SketchUp to use with OpenStudio and Radiance is that it uses a Cartesian coordinate system. What that means is that we can draw geometry or import it in here, and we can locate and define it within this environment. So the other reason is we can make changes to the model in real time and not have to go through the whole exporting process again. Why that's important is because Radiance is actually very old. As a government program, it's actually over 50 different software programs compiled together. And so if you can imagine trying to do scene descriptions and design without the mouse, without SketchUp, this is how you would do it. You would specify a center point, you would reference a text file you have written out that has commands in it. So this would be the center point. You're going to tell it to revolve a sphere around there, and that's also going to be how you're going to define the light source, and we'll get into that later. But basically, that's taken out of this book, what I consider to basically be the Bible for Radiance. It's very helpful, but it's very technical, and it might put you to sleep. So, the command line interface is how users interact with Radiance. You you have to. There's no other way. I'm sorry. There are ways to improve that interaction. One of the things we use is Console 2. It's an add-on to the regular Windows command line interface. Basically lets you scale the window, change the font, the colors, let you customize. You can have multiple paths. You can have presets to languages and command shell programs. Like you'll see in here, we have Perl and Ruby. We use Perl with RStudio. It's a flexible scripting language we use to write a lot of our scripting and automation for daylighting and energy modeling. Ruby is used because that's what SketchUp uses. So if you want to talk to SketchUp, you have to use Ruby. So you can use this on iOS, Mac, Windows, and Linux. In my opinion, Linux is the easiest because that's what it was originally written for. It was written in C. So you can use Linux operating system in the Windows computer, but you have to use a VirtualBox. And I wouldn't use that unless you understand the computer environment, how the computer allocates resources, etc., because you're basically making a computer in your computer. So you could potentially do some damage if you don't know what you're doing. The good thing about that is we now have automatic installers available. We didn't always. We used to have to manually install it. So again, if you don't understand the computer environment or you're not really too tech savvy, I would use the automatic installer. So there are some resources available for Radiance on radianceonline.org. There are tutorials available that kind of walk you through and everything like that, kind of help you understand Radiance and the computer environment. There are frequently asked questions. This one's probably the most important you'll be looking at is the message boards and troubleshooting. That's basically an email chain between people using Radiance, professors, practicers, just them solving problems. So it's very helpful to kind of go through that. If you're having an issue, someone could have already solved it. Documentation, all the commands are available and documented in PDF, so you can get a full description of the command, the variables, and everything that it can do. Be warned, it's very technical. There are references, and again, there are the installers, which I highly recommend using. That's from InRail. So how Radiance works. So this is a typical diagram on kind of a flow chart or a tree outline of how Radiance kind of organizes and works. It can kind of be divided into two parts, the Radiance command part, which kind of runs and processes the model, and then the other part, which is creating the model. So one of the best things about Radiance and why it's so effective is the way it can define materials, and it can accurately simulate how light's going to interact with that material, and so that affects your analysis. So you don't have to worry about this first line. This was before we could draw on the computer, fairly easy. This was just used so that you could call predefined geometry like pyramids, spheres, cones, etc. You could just reference those. So your modifier you're going to use is going to be void because we are importing a polygon from SketchUp. So void means Radiance is going to insert it itself into there. You have a type which defines what kind of material that's going to be. You're typically going to use plastic and glass. We'll go over that in a bit. And so then you leave this as 0. That's just a different string. The last integer argument this is what you want to worry about. This is going to give you the RGB profile of your material. That's going to determine how it reflects and interacts with light. And you can add more string arguments onto that for specularity and reflectance, depending on the material type that you specify. The identifier, this is what we're going to use to link our material definitions to our geometry objects that we've defined in layers in SketchUp. So that's how Radiance connects the two. So here's an example of all the primitive types that are available. Again, you're mostly going to be using Polygon, and that's just Radiance is going to do that itself. The materials, like I said, you're going to be using plastic and glass, but there's over 15, and there's some functions where you can customize and define your own materials as you like, completely from scratch. You can set light sources. You're not going to worry about that, though, unless you're doing electric lighting. What we do for daylight is we're going to use a generator called GenSky, and that's going to generate a hemisphere and a sky layout for how the sun's going to interact. And for more complex simulations, we can add weather data in with that. So on the right is what a finished material file looks like. So you have the void for all of them, and you have specified the type. You see metal in here. Don't worry about that. I would not use that for beginners. Then you have the identifier, and then you have the RGB specularity layout, and then you have the extra parameters that specify reflectance and specularity even further. So generating the model, this is the most important part, mostly through modeling theory of GIGO, garbage in, garbage out. So if you put in bad materials or your geometry is not correctly organized and defined, or say your sky type is incorrect in a different location, your analysis is going to be off no matter what you do. So that's very important. The other thing that's important is the OCOM feature. This is what we use, the command we use to tell Radiance what materials, geometry, electric lighting, sky type, whatever you want to make the octree file. The octree file is a data structure that's designed to store data so that the ray tracing of Radiance can access it more efficiently. I don't even completely understand it myself, to be honest with you. Basically, though, without the octree, the sorting method of ray tracing is not practical, so it wouldn't take hours or overnight. It would take months, in actual days, like real time. That's mostly for complex simulations. It's more prevalent too. So again, because Radiance is an open source program, it has third-party integration, so it's compatible with OpenStudio or Energy Plus, though it has severe performance limitations. So unless you have a beast of computer, it's really not worth investigating, sorry. I'll go into that later. Deism, Diva for Rhino. Really, most text editors, we use Excel, RStudio, and Notepad++ as our main three. Photoshop and Illustrator. And so basically, if you have the time, knowledge, and commitment, then anyone can create a plugin or user interface or overlay for Radiance to use. I'm going to show you some examples of those that we use. So this is Radiance Couleur Picker by Jaxula. There's a guy for his PhD in France developed this. And what it does is it helps you create the materials profile for Radiance. So you can specify the RGB, and you go even further, hue, saturation, and the value. You can specify the material type, specularity, roughness, and reflectance. And then you would hit render, and it will show you an example of what your material is going to look like, and it's going to have a spotlight thrown on it so you can see the interaction of it. And then it's going to output this text line that you can copy and paste into your materials file. It also has an option for choosing materials that he's defined of commonly used building construction materials. However, he takes no liability for this, so use it at your own risk. If your material is inaccurate, sorry, he's not responsible for it. So what I always say, if you're going to use a plugin or a third-party app for Radiance, always double check what it's doing, because they're not liable for it. So the most important one that I'm going to talk about today in depth that I use is by Thomas Bleacher. It's called Su2Rad, SketchUp to Radiance. And so basically, after you install it, you would go to extensions, Radiance export. And this is assuming we've organized our geometry on layers, we've edited it, we make sure there's no holes or gaps, we've made our material files, defined our materials in SketchUp and painted them if necessary. So once we've done all that, we can use this. So this is available on radianceonline.org. You can download it to install it. And so this basically does about 90% of the work for me. So here's kind of what a finished layers ideally would look like. This also has daylighting analysis grids in it. So everything's been classified to interior walls, shading devices, solar tube reflectance, solar tube glazing, window glazing. So everything's been parsed out, separated, and the model's organized. So we know where everything is. We know what we need to define. The most important aspect of this is the naming of it. Whatever you name this is that name you're going to use for the rest of the time you're using the project in Radiance. So the glazing layer would output as glazing.rad. And the material reference we would have to create would have to be glazing. That's how it would need to be spelled, not lowercase g, not missing an I or anything like that. Has to be exactly the same, otherwise Radiance will not recognize it. It will say, I can't find the file. So applying materials in SketchUp. So you can define your materials in SketchUp, though I wouldn't recommend it. Its RGB index is a little bit different than the one I just showed you with this. This goes on a scale of 0.1 to 1, and this is the typical RGB scale. So you can use this. I wouldn't recommend it. I don't use it because I have a lot of predefined materials. Most importantly, if you're doing glazing, make sure the opacity is below 100. Anything that's not glazing, opacity has to be at 100. So if you were to paint your materials in SketchUp, you would have to make sure you're painting both sides of the faces. So if you select everything and you hit the paint bucket tool and you click on it, SketchUp will paint it, but it's only going to do the top layer. So you have to go in and maneuver and paint the other end, or you can just click on this and it will show up both faces and you can paint it there manually. And so right here, this is where you would define your material name. So again, just make sure that's the same as whatever layer you're making that for. I don't do this at all. It takes up too much time for me. I let SketchUp leave the default material because then I'll go in and just replace everything, because I have a text file of a list of my library of materials that I have predefined that I'm just going to copy, paste, and then modify myself. So basically, if you've done those two steps, now we can go into the plugin. We can export. This scene is what your model is going to be named when it gets exported. So you can leave that unnamed, and it will just be called model.rad or unnamed scene.rad, or you can name it here. You want to select the mode for how you're going to export, and since we did all that work about organizing our model, we're going to go and select layers. You can select the views that you have up. That's just camera definitions in SketchUp that you can have that helps for exporting images later on. Render is not necessary. Again, I have predefined sets, but you can do that here. Materials, do not even bother with this one. It's incomplete, and you're not going to get anything accurate, so not recommended. Again, like I said, there's a more complicated render tab with more options. Each one of these, if you hover over it, it does the awesome Windows thing of telling you what it's called, so that's helpful. Again, I don't use this because I have predefined files that I reference and use. Sky type, this will help us. We can basically create our Gen Sky here in the plugin. So you can set the type of sky, the date, the time, the ground reflectance, how much reflectance. City and county, or I'm sorry, country isn't really important. The latitude, the longitude, your north degree offset, and your time zone are the most important ones you want to worry about, because that's going to affect your building position, the sky creation position, and overall where your building is going to be, where Radiance thinks your building is located in the world. So the other one, so if you selected views and you have them, you could go through here and set the parameters. I'm going to go through this a little bit later on. There's another way you can use this in Radiance itself. I have predefined files that I reference, but you can set those here. And so now Damon's going to talk about his plugin that he uses for SketchUp to make OpenStudio models.
Cool. So transitioning over to our workflow, IDL's workflow for developing energy models. I'm not saying that this is the right way. Every team has their own method of going about it. So there's definitely faults in the way that I do it, but maybe it'll be helpful for some, and you'll get just a sense of somebody wants an energy model. What does that actually entail? So the first thing to figure out is what level of detail do you actually need, and it depends on where you are in the project. And ideally, the earlier you start energy modeling, the more impact you can have. So I've kind of broken it down into 3 different levels. Level 1 would be, for example, this was a project, there was a simple warehouse, and they were wondering, is planting a row of trees along the side gonna make it a little bit cooler during the summertime? And this was just, a shoebox model is typically what these are called. And you can see, well, on a July day, it's probably not the best orientation for that. The trees aren't casting any shade onto the building. So that would be kind of a level 1, very basic analysis. We're not trying to set up a complex HVAC system or anything like that. We basically just need simple floor plans as well as elevations to see size and location of windows, and a general sense of how it's going to be thermally broken up, where the thermostats are going to be in the building. But you can do this very, very early in a project, use it kind of for a conceptual basis. And once again, use SketchUp. All of these tools, you can look online, and there's a lot of help and tutorials on there for getting to know each of the different buttons. When I am sketching a floor plan, this is, for me, the most important and most complicated part. I say it's more art than science. Dylan talked about my hesitation of importing full 3D models, because sometimes I find maybe gaps between a wall and a roof, and then air leaks out, or there's a ton of different surfaces, and the more surfaces you have in the model, the longer it takes to run. So I really dumb it down. I'm looking at accuracy of a foot, maybe 6 inches, because with these planes, they're 2D walls, so you don't have to draw certain thicknesses. So there's a lot of detail that can be in a Revit model that you don't need in an energy model. And I either just sketch from scratch usually, or like Dylan talked about, I import a CAD drawing into SketchUp and then kind of trace a simplified geometry over that. So that way I can stack my floors and have all the axes and lines line up, so I don't end up with all these kind of like splintered surfaces in the model. Once I have kind of my simple geometry, this is when I go in and I specify, if you know at the time, okay, this is going to be a separate thermal zone, or it's going to be part of something larger, and then say what's happening in this space. If it's going to be an office or a break room, something like that. So with that, you can already get a sense of how much energy the building is going to be using just from its space designations and using like ideal air loads for some of the HVAC estimates. Getting a little bit more detailed, this is level 2. This is where we start assuming what the wall types are instead of just relying on the defaults. So when I'm working on one of these models and I get a set of plans, I'm usually looking for the ComCheck page or something similar where I can see the R values or U values in SHGC of the windows and things like that, as well as the programming of the space, getting a general sense of what's happening in each corner of the building. And these can be just estimates of what the loads are going to be inside the space. So for that, I'm usually still using SketchUp, and I'm using the inspector. This way I can click on each space in my model. So I'm assigning things to the right one, and you set all of your kind of defaults. From there, I jump into the OpenStudio app itself, where I set the location and the weather file. And there's a lot of defaults that you can use for your constructions. Just say, this is a masked wall and it's about 8 inches thick. But you can get more and more detailed if you want, setting up each layer of materials and then go into each material and define its own properties. But that would be much more detailed. And normally what I do when I encounter a situation where I need that level of detail, most often somebody else has already done it. So I use what they have used. And there's this building component library, and there's thousands of different material and HVAC definitions on there. So I go and download the closest one that matches what I'm looking for, and then usually it's just a minor tweak that I need to make to it to adapt it. The loads, you can set them as a building-wide default, or you can, if you know that there's going to be a whole bunch of equipment in one space, like an elevator room or something like that, you can dive down into that level of detail. and that would be like a level 3 model. And this is what kind of LEED is looking for. LEED V4, when you're filling out the minimum energy performance calculator. I think our next BSUG presenter is going to be talking about LEED V4 and using OpenStudio. But they need to know precise definitions on the HVAC system, the equipment, you know, how it's going to be operated. And so you can, you know, define your HVAC. I usually start with a template and adapt from there if I know it's going to be a VAV versus a PTAC, something like that. And you can make some pretty quick comparisons early on, which can really help in the design. Also set your schedules, make sure that each room is behaving the way that you expect it to. And that's when I start running, and I run a lot of different iterations and look at my energy use index and see how many zones have unmet hours or are uncomfortable, if there's any space where the HVAC can't keep up with the system. And so then you might want to know, okay, I need to maybe add shading to this particular zone because it's getting way too much sunlight, or add a secondary piece of equipment to heat this stairwell or something like that. So I spend a lot of time looking at kind of my pie chart, you know, looking at the effects of different HVAC types or modes of operation or different lighting levels on my kind of energy pie. And as I'm going through this, I usually have a parallel Excel document where I keep track of each different model that I'm running. And if there's one particular parameter that I'm trying to optimize, say reduce heating or reduce lighting, then as I run these different kind of iterations, I keep track of how it affected it each time. And to do that, you can report any variable that you want out of OpenStudio. There are thousands, which is great. It can be overwhelming, but there's a list of them. And so that's when I kind of really try and narrow my focus. Okay, I've got one problem zone here. What's my problem? Is it because my plug loads are too high? Is it because my solar gains are too high? And that's where I start to make some changes to the model. And for a lot of those changes, I rely on the OpenStudio measures. Some of them aren't perfect, but they get you a long ways. And so I use it for kind of quick, comprehensive changes to the whole model. Say I want to change my window to wall ratio for the whole thing at like a level 1 or a level 2 model. You can do that very simply, very quickly. You can swap out different HVAC types and get a pretty immediate response to the question that you want to ask of the model. I also use those measures in the parametric simulation mode of OpenStudio, where I throw a whole bunch of design changes at it at once and then see which one gives me the most benefit. So just to kind of recap, level 1, you don't need a whole lot of information to get started on it, and you can have some of the biggest design changes at this stage. Level 2 is honestly where we at the lab spend most of our time. Not everything is defined, but we get a basic sense of constructions, programming, loads, and we're looking at making tweaks to that. Level 3 is going all the way. Everything is defined and hard-sized and detailed, and that's what you need for you know, LEED certification. So that's kind of my general workflow from kind of CAD drawings through energy modeling. And Dylan, I think you were going to wrap up. Cool.
Okay, so at this point, we have everything set up. All our parameters are set, our model's good to go. So we're going to hit the export button. And so this is where I'm going to talk about file structure and the edits you need to make to the text files that are exported using the command line with Console 2 and the Radiance program commands that I use most often. So on the left here, this is what you're going to get exported to wherever you set the file path to for it to export. You're going to get this list. On the right is basically what I end up with. And a lot of that is just, some of it's necessary, some of it's not necessary. Like some of these is actually for ASE and SDA simulation for LEED V4 standards. not just your regular point-in-time simulation. So what we've added is data, materials, options, results, temp, and weather. And so what that means is the data folder is where we're going to store our daylight analysis grid files. So that means that we've defined an area in the model that we want to analyze how daylight is affecting that area. So we'll go ahead and on that area, we'll create a text file to spread out sensors on it. Depending on the code or depending on what you're looking at, usually it's 2 feet by 2 feet, 30 inches off the floor for the work plane, but the code gives discretion for that depending on the window sill height. If that's lower than 30 inches, you can adjust your plane. The material files, so when SketchUp first gets exported, a material file is not in its own folder. It's just out here sitting with the rest of the model. This is your main model. This one's called lobby.rad because it was a lobby. Over here, you can see I changed it to be model 03-21-900. That's just my naming structure. We'll get that in a bit. So we moved the material file into its own folder. That's just for organizing for some of the scripts I use. The options, these are rendering options we're going to use for simulation. I use predefined. Again, that's why I didn't do anything in the SketchUp plugin. The results folder, this is where we're going to store all the results that we get from simulation in Radiance. That's where it's going to place them. The temp folder is not necessary for more basic simulations. It's more for complex ones where Radiance needs to temporarily store information. The weather folder is where we're gonna sparse out our weather data with our sky type and model. That's again for more complex simulations. So here's an overview of the entire file structure that I got and what it all means. Not going to go into much detail. We're running short on time. Sorry. Again, for the files, keep naming the same. It's very important. So the reason why I changed this is it helps me keep track of the simulation I'm running. So model, because I'm lazy and model is really short and easy to write, I use model. You can change it to whatever project name you would like. 03 means March, 21, the 21st of March, 900, 9 a.m. So that's when the simulation is taking place. And so that helps me keep sorted. So, if I want to run multiple ones like this one, I'm running at 3 p.m. on the same day. Typically, you're going to see March 21st or September 21st, fall and spring equinox. So those are the typically most used by code. And then I've added a command line text file. This is kind of just like my workspace where I write out the command lines I'm going to put in the console to, just so I can check it and see it. And I write from beginning to end all the commands and all the lines I think I'm going to need. So that way I can just go. So this is what I mean by checking what is being exported by the plugin. If I get this on the left, I know it's going to be a good day. If I get this on the right, I know it's going to fight me a little bit. So what's missing here is for all these objects, this is the material or the model.rad folder that you're going to get. And so what this does is it stores your sky data, your material data, or references your sky data, your material data, and your objects of where they are in the project folder. So Radiance can go and find them. So here, these are all missing callout directories. So just // to let it know to go pull it from a directory folder. And so we need to add those in. The sky one we've updated and changed. I use the same naming structure, so it's 321-900. So that's what the sky is set up for. On the materials, I've added just another directory step because we can put it in its own folder. And some of the things I do is I like to separate out the window groups, north, south, east, west, so I can do a more detailed analysis or clipping mask. That's usually required for more complex simulations. The simple ones, you generally don't worry about that. You can just leave the glazing with the objects. But the other reason why I'll keep doing it even for a simple one is because of predefined scripts that I use. I don't want to go in and change it. So on the left is what you're going to get exported, or at least what I get exported if I leave the default SketchUp material on there. So it will define it as we talked about materials earlier. So you have 0, 0, and then the number, and then the string argument. So there that is. And so because we didn't actually go in and define the materials in this example, they're all left like this. So here's a finished one, and I'll typically have a list, like over 100 lines of just this, and I'll just copy and paste and just replace, and then I'll edit as simulations go by, kind of fine tuning and tweaking it. But the right is a material finished file. So for the sky, we're going to use the Gen Sky, which produces a Radiance scene. This is kind of an example of what the argument looks like. This is set in Boise. There's a latitude, longitude, and the meridian. You can specify sunny, cloudy, the date, time, ground reflectance, and there's more arguments you can add on. I would typically just I would go to the Radiance online site. They have libraries as well of these, and I would just use theirs. The defaults don't mess around with these. These have been the rigorous testing and training from people that have done it, and they're like, this is what we feel is the best. So that's why we use it. So I would just leave those options alone. No. So here's a command file. This is like probably a third of it that I use, like I said, in my workspace. So again, this is me just writing out all the commands at once. This is single line, and I'll test a couple of these, and if I get them working and everything's running properly, then I'll write it into a single argument, so I don't have to put this in 10 times or however many times. I just copy and paste it doing once. It's also, I keep a running sheet of this, with dates and comments in it, so I can keep track of what I've changed simulation to simulation, so I understand where my model's going. So here's the file directory that I said you would have to work in, and so basically to access that file directory, the console 2, you're going to set the directory with the command CD. This is where it gets kind of tricky depending on the OS you're using, because depending on the operating system, the commands are different. So for this one, the default is Control Insert to paste, not Control V. With Mac, it's different. The reason why we like to use console 2 is you can go in and change that. So you can put it back to Control V, and you can change other things to help you work in the space. So that's the other reason why you use it. So here's an example of what that command looks like. And so then it would set Forward 1518 to be the project folder. And again, that's just the simulation I ran that day. That's why the folder is called that. So we're going to skip the OB object to Radiance command because we used our plugin. So that's a step we don't have to worry about. And I'm running short on time. The most important variables to set is the ambient parameters. That sets up how Radiance is going to define the bounces and interaction of light between your model. So there's 4 ones you want to worry about: bounces, division, accuracy, and resolutions. They look like this. You type in negative AB, and then the N would be the number. So that would determine how many times light's going to bounce. Again, I would not do this on your own unless you're a nerd and you want to test and see cause and effect. I would use download from radianceonline.org, go look at their definition, and they have examples. They put it through rigorous testing to the point where we can get predefined files, options that we reference and use that give us the most definition and accuracy for a simulation without making the simulation time crazy. So it's how accurate can you be while reducing time. And so there's actually, I'll show here. There's 5 variables set here, more than the 4 that I've shown you. There's actually over 20 you can set. You can get really, really detailed and crazy with it. So you have low, medium, high, and that does what it says. So this is what it looks like. Again, there's another one that I use. I have plenty of those. And so this is what the argument looks like. So instead of having to write this into the console, you're just going to put down here call the folder options, and then select the option low.opt. So rather than writing all this out, you can just write that. So it makes things go a lot faster, referencing your text files. Here's an overview of the commands I most use in Radiance. Because we're short on time, I'm only going to go over rtrace and rcalc, the 2 most important for running daylight simulation, or at least the one for code that everyone's most concerned with. So rtrace is going to take 1 or more arrays and basically bounce it around the model and kind of define what a scene is going to look like. And you can specify that. And so what your sensors are going to do is they're going to take that data because it's going to be tracing, and they're going to basically be there and they're going to record the activity that happens. So to define sensors, you're going to basically use the Cartesian coordinate system. Again, that's why we love it. You're going to set the X, Y, Z, and then you're going to set the X direction, the Y direction, and the Z direction. So basically where it's located and then where it's looking. Is it looking down? Is it looking up? Is it looking at the wall? So you have to specify that. So you can place one along the wall, on the ceiling, or generally what we do is at the work plane. So this is what a text file looks like for sensors. Real fun, right? And so basically we'll run the RTrace, and this is what it will give. Radiance will give a text file that corresponds to the sensor and what it's recorded. So after it's recorded, we need to go get it. But first, here's an example of how to use RTrace on the command line. Here's a grid that's been I've rendered for you. So basically, this is the daylight area traced, and then we did basically a grid of sensors, and so then Radiance is going to pull all the ones within that shape and use those. And so they're going to get the results, and that's basically what it looks like using command line. So after we got the results, we're going to use rcalc. We use this variable string right here. Again, use the defaults. I could give an entire presentation on why these numbers are important. There's a lot of math and time that went into defining those. So you take your RTrace file. We're going to define where it is. So it's in the point time simulation for this, and we're going to look at the day room, and then we want it to output to our results file as that. So here's the results it's going to get, and so it's just a list of numbers, and that's the lux value that each sensor is reading at that time. So not helpful to me, like I can use this right away for information and making changes. Not so much for clients or anyone else. So we do a script where we plot it. We can set the scale of it and the parameters. So this one is set. Anything below 300 is going to register as a black dot, so it's not meeting the basic performance standard. And then we can set a maximum of 4,500. So all these big circles, that's has a value of 4,500 lux or higher, so it's out of standard. So that's something we need to work on. And so we can get a percentage on how effective the space is meeting the code requirement. Okay. So pros and cons. It's open source, compatible, so cost of it's free. You can demonstrate the effects of design or lighting decisions. You can run detailed simulations that accurately simulate light behavior in complex environments. And for me, math and coding, because we're going to nerd out. The cons would be the user interface, troubleshooting. There's no one you can call. You're just going to have to piece it together yourself. I'm sorry. Hardware requirements. Again, if you don't know what you're doing, your simulations could take days and could just really. I would not recommend doing this on a laptop. And the con would be math and coding. So, did you want to talk about this at all? Yeah. Then real quick, you're probably wondering, are Radiance and OpenStudio compatible? Short answer is yes, but they don't play well together. Most of that is just because of the way data is stored in reference in OpenStudio and Radiance. It's different. Like I said, OpenStudio doesn't use the octree file format. But people are working on that. The last conference I went to in August 2017 was Rob, I'm not even going to try that, from NRail, gave a presentation about using the parametric analysis tool with OpenStudio. Can you just use Radiance and daylighting parameters in OpenStudio? The answer is yes. Here are the possible features. A lot of these they actually ended up adding on and fixing. So you can add shading controls, you can add photo cell sensors, other sensors. You can automatically generate that if you have a Radiance model defined. But running Radiance on an entire building as a resolution to support complex fenestration and dynamic daylight metrics is incontractable. There's not enough time, not enough memory, and not enough storage. And the cloud just kind of masks the mountain. Basically, that's taken directly from him. Those are his words. So I know that was clear as mud. So any questions? And I'm sorry I rushed and I crammed a lot of that in there. So other than the numbers, so you can have Well, the first one is, so we do a plotting. We can do this as, dots, or we can do it as a gradient. Takes a little more work because we got to get the floor plan and, work a couple more steps. There's an art picture option, which basically this goes off of any cameras you predefine. That'll be helpful, so you can render a scene and see what it looks like. So in here, you would do, this is a very, very basic command line text. So you RVU, which is viewing the simulation. Just going to set the basic bounces, so AV2, and then you're going to call your octree file. And so it's going to open it up in this one because I didn't bother to define the 3D view right off because I had views defined by cameras. So I'm going to go to load view, navigate to where I have those located. Those are blacked out because the project can't be seen, sorry. But you would select one and it would load the camera that you defined in SketchUp. I'm over here. And how you navigate, again, this was the view options in the plugin. You can set where the camera is, the type of camera. So you can make a fisheye, you make it panoramic, quite a variety of range of options. Then can't really see that. Sorry. The viewport. So that's determining where the camera is looking, where it's located, how it's looking, and then where's up. So you can 360, a lot of options. And so from there, we take that, we can make an HDR of that. We can do a false color. We can do run a clipping mask through Photoshop and Illustrator. And then so we can do glare analysis. So there's quite a bit of options that we can do to view the model. Yes. The other thing, if you'll notice on the front of this book, it's just a nice rendering. So you can get photorealistic images of your projects, just because that's the way Radiance defines the scene through the backwards ray tracing. I would caution you on that. I don't like to give clients photorealistic, like this is what it's going to look like in the real world. That's not the point of it. You want to use it to show the cause and effect of design decisions through lighting. And if there's going to be glare, it can be real helpful too for convincing your client to get a light shade or add shading devices in, things like that. If you want to, you can do that pretty picture for the board and get that nice rendering. That's entirely possible. That involves, however, using much more than just 4 ambient parameter options. You're going in about 10 to 15 variables using that because you're just setting a lot of parameters for that. So, yes. Every single time I do a project. Like I said, some of the tips and tricks would be naming the layers. It's all the way back there. Naming the layers, just double checking your families, making sure your walls are connected to your roofs. Just basic things like that. I mean, if you want yourself, you can do the export process yourself and import it into SketchUp and see, is my model, can I work with this myself? Would I be happy receiving this model? You can ask yourself that question. Oh man, that's a really long presentation. Sorry. Like I said, I have my own workflow down on how I do this and how I go in. Like when I get a Revit model now, I don't immediately export it. I'm like, okay, what did this modeler do? How are they modeling? What do I need to change? So yeah. Any other questions? Yeah. I would say Rhino is probably what I would use if I wasn't using SketchUp. The reason why is that Rhino uses actual math to make its geometry, like I said, like what Radiance does. So, for example, in SketchUp, if you draw a circle, that's not actually a circle. It's a line, a line, and a line, and a line, so connected. So that's why I would use Rhino. Grasshopper I've used before for my thesis. It's really good for just being able to map things out because you have to pull and plug in and set parameters and reference them. It's also a really good flexible interface for coding. Diva is good for electric lighting. I can't speak to Ladybug or what's the other one, Honeybee? Yeah, I can't speak to those. I'm sorry. Was there any energy modeling in there? Yeah, and so the real difference between Rhino and SketchUp, so the coding and command line interface in Rhino is actually available in SketchUp. You just have to go find it and tell it that you want to use it. You have to click the button to show it on. I've used it in my thesis before to generate entire city blocks of geometry that I didn't want to draw. So, yeah. No, project funding doesn't go that far, and most people they don't really care about it, unfortunately. That's probably something I would just do in my own personal free time if I thought a project was really interesting and I wanted to go do a deep dive into it. Then I would, then I start running other more complex simulations and just tweaking it because I just want to know what if. So yeah, sorry. Okay, that's all the questions. Thank you.
Yeah, and feel free to pick their brains afterwards. I'll just give you guys an opportunity to grab some more food, leave, whatever. And again, we are always happy to assist either just running the models for you. I recognize Radiance in particular has been a real hurdle for people to overcome. It is, however, the best daylighting tool out there. We found that other programs, either built into Revit or the Green Studio, they just aren't doing the same kind of level of modeling. They do point in time okay, but if you want to look at glare and other sorts of things, they're just not quite there yet. Maybe they will be at some point if the demand is greater, and maybe Lead before we'll push that with ASE. But again, if you want to give it a shot, both with the Energy Plus and OpenStudio side of things, and with Radiance, we are also happy to just give you private tutorials, help you guide you through it, make you more proficient. We can, some proficiency with eQuest and other modeling tools that we can assist with that. Train trace don't bother us. Offend a whole bunch of people online. But yeah, please feel free to use our technical design assistants for those things, either in full or to assist you and guide you guys in bringing it in-house. That's what we want to see. So, and before you go, I picked today's. We've got Ken Gallegos and Sam Bowman. Is it Bowman? Yeah, Borman. Yeah, I was like, that doesn't sound right. So we've got a couple of door prizes for you guys.